Welcome to a new series on sensory technology. As industrial processes get more and more complex, there comes some means of monitoring industrial activities. In a process plant, the programmable logic controller, also known as PLC, uses sensor to gather the speed of moving objects, the position of an object, and many more. The PLC need this data for further processes. These sensors are classified into two. That is the proximity sensors and contact type sensors. Proximity sensor are type of sensor that does not need to be in physical contact with the sensing object. An example of this type of sensor are inductive sensor, capacitive sensor, and photoelectric sensor. Limit switch, on the other hand, is an example of contact sensor. We will be starting with photoelectric sensor. Photoelectric sensor is an electronic device that uses beam of light to detect objects. They are mostly used in manufacturing environment to gather data in moving objects, and to also monitor the manufacturing processes. Photoelectric sensor comes in three types, which are Retroreflective Sensor, Through-beam Sensor, and Diffuse Sensor. In retroreflective sensor, beam of light is emitted through the emitter. The light beam will travel to a reflector. The reflector will reflect the beam ray back to the sensor. For the reflected beam of light to be reflected back to the sensor, the reflector must be properly aligned with the sensor. When the beam path is not obstructed, the indicator light will be on. But when the path is blocked, the indicator light will be off. The retroreflective sensor comes with its own drawback. The sensing distance is very short, because the reflected beam will have to travel back off the reflector to the sensor. This makes the beam intensity to drop as the distance increases. Hence its short distance. For the sensor to work, it must be installed with the reflector. Through-beam photoelectric sensor. The through-beam sensor consists of the emitter and the receiver. The emitter will send a beam of light to the receiver. When the beam reaches the receiver sensing indicator light will be on. The emitter and the receiver must be properly aligned with each other before the beam will be received by the receiver. When an object comes between the emitter and the receiver, the output of the sensor will be off. Again, the sensing mode of this device can be preset. The available mode are known as light on mode and dark on mode. For light on mode, there will be an output signal when the path of the beam is not interrupted. While in dark on mode, there will only be an output coming from the receiver when the beam is interrupted. Unlike retroreflective sensor, the sensing distance is large, because the beam is not reflect off any medium. Instead, the beam will be received by the receiver. Diffuse photoelectric sensor. In this type of PE sensor, the emitter and the receiver is built in the same housing. So for the sensor to work, the beam of light coming from the emitter will be reflected off from the sensing object. The reflected beam will travel back to the sensor and it will be received by the receiver. Some diffuse sensors also comes with light on mode and dark on mode. This type of sensing device also comes with its own drawback. The sensing distance is the shortest among photoelectric sensing device, because the emitted beam must be able to be reflected back to the sensor. hence its length. Now let's do a quick recap. We started off with retroreflective sensor. We look at its working principle and its drawback. From there, we look at through-beam sensor. The working principle of this type of sensor was also discussed. We look at the available mode configuration. Finally, we ended off with diffuse sensor. The working principle of this type was also discussed, and its application in industrial setup. In the coming series, we will be looking at inductive sensor as related to industrial use. Hope you have learned something today. See you in the next series.